4479. What is it and why? Given by Senna Davis. Macromolecules. There's 3 of them. We talked about them either today or the day before, and I want you to go check your interactive notebook. You can pause this really quick. You should look at page 2 and write down the 3 macromolecules that are affiliated with nutrition. So you probably looked and remembered that they were proteins, carbohydrates, and lipids. Proteins, carbohydrates, and lipids. Yes, there was nucleic acids, but we're not concerned about that for food or for the 4479. I want you to recall that proteins are made of amino acids. Carbohydrates are made of ring structures containing carbon and hydrogen, and then lipids are made of long chains containing carbon and hydrogen. So I want you to notice that carbon and hydrogen are involved in carbohydrates and lipids, but honestly they're involved in proteins as well. But we just call them amino acids. But amino acids is just a specific name for carbon and hydrogen. Okay, so energy. Energy comes from chemical bonds. And remember how I just talked about carbon and hydrogen? They are found in all the macromolecules. They're included in those amino acids, the ring structures, the long chains. So all macromolecules have energy. Now I want you to look here. Whoa, I want you to look here. If you look at a carbon-carbon bond, let's look at this graphic here actually. It's a graphic of bond length in units of picometers and bond energy in units of kilojoules per mole. We're going to talk a little bit about moles later and kilojoules here in a moment. So this first number is the bond length, which let's ignore that for now. What we're really interested in here is the energy. So if you look at a carbon-carbon bond, it has 348 kilojoules per mole. All that is a unit of energy per amount. You can look at over here. Where'd my mouse go? There it is. If you look here, carbon-hydrogen has 413. So a carbon-hydrogen bond actually stores more energy than a carbon-carbon bond, right? Because 413 compared to 348. Bottom line though, I want you to get that there are energies, there is energy in bonds. Ooh, this is cool too. Look at this. These 2 lines here, that's called a double bond. And check out how much energy is in a double bond of carbon. 614 compared to 348. Hey, by the way, they referenced it for us right above it. Double bonds, by the way, are pretty commonly found in lipids. For example, omega-3, omega-6 fatty acids. I think you've probably heard that before. It's in things like fish and olive oil. They call it the good fat. Just so you know, that omega-3 and 6, want to know what the 3 and the 6 stand for? That's where there is a double bond, just like this one, between the 3rd and 4th carbon and between the 6th and 7th carbon. Got a little technical on you there, but that's okay. So this is a graphic of energy. All right, let's keep going here. So units for energy. In food, the unit of energy is a calorie. I think we've all heard of calories before. And then another common unit of energy is a joule. We typically don't say, so how many joules are in that cheeseburger? We use calorie, but it's fine. It's kind of like the difference between inches and feet. They both measure length. They're just called different things, and the same is true with calories and joules. In fact, if you look back at this graphic here, remember kilojoules per mole, that capital J stands for joule. This lowercase k is kilo, which is just 1,000 joules. And then a mole is a quantity. It's an amount of something. All right, so let's keep going here. So now you see this chart. Let's look at it. So I have how many calories there are per gram 4479. Okay, this is the name of the whole workshop, so now let's talk about this. I'm going to tell you about macromolecule name, the chemical structure, and an example. All right, so for a carbohydrate, there are 4 calories per gram. It doesn't matter what the carbohydrate is. It could be, for example, bread, but it could also be other things like tortillas, rice, cereals, pastas, all of those things that we call carbohydrates. For every gram of them, they have approximately 4 calories. And remember, the structure is a ring containing lots of carbon-hydrogen bonds. The next 4 is 4 calories per gram for every protein. Now remember, protein's made of a chain of amino acids, and remember how I talked to you about how the body chops up the protein so that way it breaks it down into the amino acids and then uses those amino acids to make new proteins? Well, when you break apart those amino acids, energy is stored, and you get, in fact, 4 calories per gram of energy when you break down protein. Just for fun, I reminded you that protein is in things like chicken, but it's also in things like beans and eggs and nuts, other meat products. Now we have this random 7, and the macromolecule name, alcohol. It's not a macromolecule. In fact, it's actually small. So the chemical formula for alcohol is C2H5OH. And in fact, the formal name of this is ethanol. An example is tequila. Yes, I'm talking about alcohol, beer, wine, tequila, vodka. As adults, we start to drink alcohol, some of us, and it is important for us to understand when we're talking about nutrition that those alcoholic adult beverages do in fact have 7 calories per gram, and that's kind of a lot compared to proteins and carbohydrates. And then the big one of all, 9. 9 calories per gram for lipids. And remember, lipids are long chains of carbon and hydrogen. And an example of that is olive oil. I want to point out a difference structurally between lipids and carbohydrates. Remember, a carbohydrate's a ring and a lipid is a long chain. And what's great about lipids is that they are very dense. So these long chains allow for a heck of a lot more carbon and hydrogen to be shoved in a very small space. And because of that, there is a lot of energy stored in those carbon and hydrogen bonds. And because of that, that is why there is actually 9 calories per gram in a fat compared to only 4 calories per gram in a carbohydrate. Okay. Pause this. I'm about to change the slide, but if you're not done copying this down, you should pause this. And next. Okay, so let's do a little practice. Say a food has 5 grams of fat, 20 grams of carbs, 3 grams of protein, and I want you to do some calculations and figure out how many calories total does this food have. So you'll add, and I say hint, add these all up. So I want to show you what I mean by the first step. So remember how I told you fats have 9 calories per gram? So what you would do is you'd say, okay, 5 grams times 9 calories per gram would give you a total of 45 calories. Notice that the grams canceled. This is a gram on top and this is a gram on the bottom. And you simply just say 5 times 9 gives you 45 calories. So now I'd like you to pause this screen and you practice by filling in we're going to call this a conversion factor, this 9 calories per gram. Fill in the conversion factor for both carbs and protein, do the math, and then add them all up. By the way, where did I get that conversion factor? I got it from here, right? 4, 4, and 9. Okay, so pause. Oops, there we go. Pause. Now fill that in. And when you unpause, then I'll have the answer. Okay, so hopefully you put the 4 calories per gram for carbs, 4 calories per gram for protein. You did the math, right? 20 times 4 is 80, and 3 times 4 is 12. Then when you add them all up, 45 plus 80 plus 12, you get a grand total of 137 calories. So if a food had this on its nutritional value, you could actually calculate the total calories of the food because all calories come from these three macromolecules, nothing else. So things like vitamin C, iron, calcium, those have no calories. They're important, but they do not have calories. They do not provide energy. Okay, so tomorrow I would like you to bring a food package with a nutritional label, and we will practice doing some more calculations together tomorrow. In case you're wondering what a nutritional label looks like, it's this thing. It's often on the sides of your cereal boxes, on the backs of your pastas, on your lunch meats. So if you could steal a nutritional label off one of your foods from home, that would be great. Toss it in your backpack and we can all share them tomorrow. Okay, thanks for listening.